Okay, on number 14 we're going to solve by graphing. We just want to graph the equation. I would probably use Desmos just to graph this and then show me a picture of it. Okay, so I've put it in Desmos and you can see what the graph looks like. You might need to make it a little bit smaller to see the whole thing. And so what I would do is I would identify on your graph the vertex and the points of intersection. The points of intersection are actually your solution. And so we've got 2, 0, and negative 4, 0. Those are our solutions. And the vertex is negative 1, negative 9. So if you have those 3 points, you can graph it, and then the solutions are x equals negative 4 and x equals 2, because it's where it crosses the x-axis. So that's what I'm looking for there. And of course the graph. So there were our points, and then I don't have the whole thing on here, but I've got negative 1, 9 would be about right down in here, and so there would be my graph, roughly, very roughly in that case. Okay, on number 16 it says we've got a function and it models the height, y, in feet of a stone t seconds after it's dropped from the edge of a cliff. How long will it take the stone to hit the ground? Round to the nearest hundredths of a second. So what I would want to do is graph this, and it's going to look like on the graph something like this, where when x is 0, that's when we drop it, and then we want to know what this value is right here. What is x at that point? Because that's when it hits the ground. So I'm going to go graph it on Desmos. Okay, so I graphed the function, and you can see where it starts. And so this is the top of the cliff there at the vertex. And the stone comes down and it hits the ground at this point right here. So I want to know what that point is. So where the stone is thrown is at that vertex there, and so it says at x is 0, so that's 0 seconds, and it's 486 feet above the ground. And then it's tossed off the edge, and it hits the ground down here, and it says x is 5.51. That 5.51 is the number of seconds it's taken the rock to hit the ground. So that's all I do. I graph it and I see where it hits the x-axis, and that's the point at which it hits the ground and stops. So that's like the side of my cliff, and this is the ground. So the answer was 5.51 seconds. Number 17, we have another function. This one, for some reason, it didn't print off enough information, so we can't really do that one. We're going to just mark that guy out. Number 18, what's the solution of the equation? So we want to work that one out. You're just going to solve for x, divide both sides by 3, and you get x squared equals 7. And we want to take the square root of both sides. So you get x equals plus or minus the square root of 7. And you just leave the radical there because I can't actually take the square root of 7. Number 19, it says the lengths of the sides of a rectangular window have the ratio of 1.2 to 1. When it gives me a ratio, that doesn't mean that's the actual length, it just means that's like the reduced form. So the longest side is going to be the 1.2. And I'm going to say 1.2 times x. Okay? And then the width, that's going to be 1x, because again, it's some reduced form of the ratio of the two. The area of the window is 1,920 square inches. What's the dimensions of the window? So area is length times width. If the area is 1920, and that's equal to the length, which is 1.2x, and the width, which is 1x, I have a little equation out of that. So I have 1.2 x squared equals 1920, and then we're going to divide by 1.2. And you get x squared is equal to 1,600. We're going to take the square root of both sides. Take the square root of both sides and you get x equals plus or minus 40. It wants to know the dimensions of the window, so that's just x. Remember, the dimensions were 1.2x by 1x. So if I put 40 in there, if I put negative, it's going to make the dimensions negative. I can't have negative dimensions, lengths for window, so I have to put positive 40. So that's a case where one of the values doesn't work for us. So I'm going to use x equals 40 for this and substitute x into the equations. Well, 1 times 40 is just going to be 40, so that's going to be the width. And then 1.2 times 40 is going to be 48. So the dimensions are 48 inches by 40 inches. That's our dimensions of our window. Number 20, we want to complete the square. So it's just really asking what are we adding to this to make it a perfect square trinomial. You take your negative 18, divide it by 2, is negative 9. And then you're going to take that negative 9 and square it and get 81. So 81 will complete the square, so that I get x squared minus 18x plus 81. 21 says solve the quadratic by completing the square. So normally if I have a quadratic, I have to take the constant term over to the right side. Well, the constant term's already over there, the negative 5. So I want to divide by both sides by negative 3 because I want a constant, or I want a coefficient of 1 on the x squared. So let's do that first. So I have negative 3, I have x squared minus 7/3 x, and then I'm going to complete that side over 5/3 plus whatever I put on the left. So if I put something on the left, I have to put the same thing on the right. I'm going to do the same thing to complete the square. I'm going to take the middle term, it just happens to be a fraction, and divide that by 2, which is the same as multiplying by 1/2. So that's negative 7/6, and then you have to square it, which is 49 over 36. Okay, then I want to take my perfect square trinomial that's on the left side, and I'm going to factor that. That's going to be x minus 7/6 squared, and that's going to be equal to, if I change 5/3 to a denominator with 36, I'm going to have 60 over 36, and you add those together and you get 109 over 36. and then I'm going to take the square root of both sides. That's going to be x minus 7/6 then equals square root of 109 over 6. And then you're going to add, that's going to be plus or minus, and then you're going to add 7/6 to both sides. And actually the proper way to write that is going to be 7 plus or minus the square root of 109 over 6. So that's my final, should be my final answer. Okay, on 22 you want to rewrite that in vertex form. Vertex form again is y equals a times x minus h squared plus k. Now I can complete the square and do it that way, but to get the vertex form, and I can also just find the vertex and plug the values in, which is kind of easy, or much easier. But I want the vertex, which is your hk, and I want the y-intercept. Well, that's whatever c is. This is c in standard form, so because it's y equals ax squared plus bx plus c. So the y-intercept, that one's kind of an easy one. The y-intercept is 382. So that's part of our answer, and then we just need the vertex. And we can get the vertex by doing that axis of symmetry equation we've done a couple of times. X equals negative b over 2a. B this time is 30. And then we've got 2 times 3/5. That's going to be negative 30 divided by 6/5. Remember to keep it, change it, flip it. So that's negative 30 times 5/6, which is going to be negative 25. So we get x is negative 25. That's part of our vertex. We just need the y. So we've got to solve for y in our equation. We're going to put negative 25 back in the equation. Plus 30 times 25 plus 382. And we'll see what we get there. And we get 1,507. So this has a vertex of negative 25 and 1,507. So that's how I would do the vertex. And then we just want to put it in vertex form. The vertex form, if it's y equals a times x minus h, this is your a here. So we get y equals 3/5 times x minus h, so h is negative 25, that's going to be x plus 25 squared, and then plus k, and k is the y coordinate, so that's plus 1,507. So there's my answer there. Number 23, you just have to use the quadratic formula. Just be very careful with that. We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is negative 1, b is 6, and c is negative 5. We're just going to plug those values in. So negative b, which is negative 6, plus or minus the square root of 6 squared minus 4 times negative 1 times negative 5 all over 2 times negative 1. So that's negative 6 plus or minus the square root of, under the radical, we're going to have 36 minus 20, so that's 16, over negative 2. And so that's negative 6 plus or minus 4 over negative 2. So one's where we're going to add 4, one we're going to subtract 4. If we add 4, we get negative 6 plus 4 is negative 2 over negative 2, which is 1. And if we subtract, we get negative 6 minus 4, which is negative 10 over negative 2, which is 5. So my solutions are 1, negative 5 for that one. Number 24, I'd follow the same rules. You just have to make sure that it's quadratic formula again, but I have to bring over everything to one side first. So negative 4x squared plus x plus 4, because the 4 is going to come over, is equal to 0. So that my a is negative 4, b is 1, and c is 4, and follow the quadratic formula. Number 25, we're going to simplify with imaginary numbers. Basically, you take out a negative 1, and so I have negative 1 and 144. Well, the square root of negative 1 is I, and the square root of 144 is plus or minus 12. Now I don't want to put I don't want to put I times plus or minus 12. I want to put plus or minus 12 and then I at the end, so that's my answer. 26, to simplify, we're going to treat this just like exponents, so I have I times negative 7i, that's negative 7i squared. But what we found out is I squared is a real number, which is equal to negative 1, so that's really negative 7 times negative 1, so we have a solution of 7 is the product. Number 27, what are the complex factors of the equation? Complex really means that we're probably looking at having an I as a factor, and factors are something times something. So I'm going to solve for x squared and basically work backwards. So subtract 36, that's 49x squared equals negative 36. And then I'm going to take the square root of both, well, actually, I'm going to back up just a little bit. Sorry about that. Let's divide by 49 first. Okay, so that I get x squared equals negative 36 over 49. Okay, now I can take the square root of both sides. And when I do that, I get x equals, anytime I have a negative, I just know that I'm going to have an I in the answer. So keep that in mind that that's going to be the end. And I'm going to have plus or minus, the square root of 36 is 6, the square root of 49 is 7, and then an I. So that's how I would write my answer. On number 28, it says to graph to solve the system of equations. I'm just going to put these in Desmos and see where the two equations intersect. So let's do that. Okay, so I put both equations into the graph, and you can see that I have a parabola. Make it a little bit bigger, darker here. You can see where I have a parabola, which is the green equation, or graph, and the purple one is my linear equation, and their points of intersection would be my solution. So they intersect at negative 2, 4, and 4, negative 2. So those would be my two solutions for that particular problem. And that's how I would list it. Now you do want to go ahead and graph that. We said we had at negative 2, 4, which would be right in here, and 4, negative 2, which would be about right there. That was actually our line going through there, and then the parabola looked something like this. Please give me a more accurate graph than that. But those were our solutions. Negative 2, 4, and 4, negative 2. You can do the same thing for 29 and 30. Just graph the equations and look to see where they intersect, and their points of intersection will be the solution to your equation.